Hello and welcome to another Solana tutorial. We have finally reached Module 2 of the Solana Development Course, and today we're gonna talk about the token program and interacting with the token program. Now, not to brag, but I know the token program pretty well. Like from all the Solana programs, I know the token program the best because I worked a lot with it. And I'm assuming that most devs will work the most with the token program because it's just the base for everything that you want to do. Pretty much any app will need the token program. So today in part 1 of module 2 of the Solana Development Course, let's create tokens with a token program. So let's go ahead and jump in. Module 2, Part 1, Creating Tokens with a Token Program. Today we're gonna learn how to create token mint, how to create token accounts, mint tokens, transfer tokens, and burn tokens. Pretty simple stuff if you ask me, but if I ask you, maybe you don't know about that. So here we are, learning about the token program. Some basics. If we talk about tokens on Solana, we're talking about SPL tokens. Solana Programming Library tokens. They represent pretty much all tokens on Solana. Non-native means that are not SOL, because SOL, the cryptocurrency, the coin, the native token of Solana is only SOL. So any other token is non-native, is an SPL token. You can also wrap SOL in an SPL token, but that's a different story. And both fungible and non-fungible tokens, NFTs, are represented with those SPL tokens. On Solana, there's no real difference, except for, the amount of tokens per mint. Now, the token program is responsible for handling all those tokens. Same way the system program is responsible for handling the native token and the accounts. The token program handles all the accounts for SPL tokens. Now you can write your own token program and handle your own tokens with your own program. You can do that. But in Solana, contrary to Ethereum, where every token might be their own smart contract, there's one program, and that program handles all of the interactions with tokens. So if you want to create a new token, if you want to mint tokens, if you want to transfer tokens, burn tokens, that's all done with the same program. It's just how Solana architecture differs to other blockchains. Maybe a quick fun fact, the token program is so important, it handles all of the tokens, which means it handles a significant amount of value. There's USDC as an SPL token, there are all sorts of other valuable tokens that are not SOL on Solana. And this program handles them all. So obviously, it's an important program. It's also a native program, so like a program that Solana developed themselves, like the core engineers. The funny thing is, this program is so important that they didn't even want to change it when they wanted to add features. They rather proposed a new program, the Token 2022. But also this is the topic for other videos. So today we're just gonna interact with the token program, create token mints. A token mint is just the one account that represents one token. So if I have USDC, there's one account that says how many USDC there are in existence, what the decimals are, and all that stuff. So holds the data about the specific token, but not the tokens itself. The tokens themselves, they are held by token accounts. So a token account essentially just says this owner holds this many tokens of a specific mint. So in the token account, there will be reference to the mint, to the owner or authority who is allowed to transfer those tokens, and the amount of tokens in that token account. Now, creating accounts in general requires rent in Sol, and we're apparently also gonna learn about that in this session. And if we close a token account, we can get the rent back. This is the main idea of my fee redeemer application. It allows you to close empty token accounts to get the SOL back. So I do have videos on this channel that talk about like most of what we're gonna talk about here. This will be very like programming focused, how to do this with Solana Web 3 or the SPL token library, I'm assuming, and not so much CLI. My first ever video about Solana was about the token program and how to create a token with the SPL token CLI, so you can also check that out. Might be a bit outdated by now, but yeah. Token mints can currently not be closed. That's also true. Once you create a token, it will be there forever. You cannot delete that anymore. This account will be persisted on Solana forever. It's going to change with the token 2022. The accounts you create there can be closed if you set the right flags. All right, so jumping in. Maybe start with a more general outlook or overview, because we might have skipped that when we read the header of this module. In Solana, there are programs that you can just interact with. In module 1, we interacted with a program that James deployed. In module 2, we interact with Solana programs. So that's, I want to say, native programs. So programs by Solana Labs that just have a lot of functionality. So on Solana, you can do a lot of stuff, actually build your own dApps without ever deploying a program on chain. Just by interacting with existing programs, you can already do quite a lot of stuff and build applications. And so the token program is just one of those programs that we're going to interact with. And I would argue it's the most important program that we interact with. Yeah, it's part of the Solana programming library. If you don't know where you find that, just Google Solana programming library and you will find their GitHub. And in this Git repository, there are, many different things, but one of them is the token program. There you'll also find the token 2022. But this thing here, this is the token program. And I always suggest people go have a look at this, especially the state stuff is interesting. There we see what is stored in a mint. We see what is stored in a token account. I suggest you just read through that. Anyhow, coming back to our tutorial, in this lesson, we focus on the basics. Okay, fair enough. And we create a new token. So we create a new token. We create token accounts for this particular token. We then create the tokens. So first we say there is a token. Here, when we create a token, there is a token, but then the circulating supply is still 0. And then when we mint, we create the actual tokens such that there are tokens to send around. Same word, but different concept. Does that make sense? I talk with my hands a lot. I will keep doing that. And then we can, of course, transfer tokens, and transferring tokens work from token account to token account. If I want to send somebody a token and they don't have a token account yet, then I need to create a token account for them. I can also create a token account for them anyway. There will be the concept of an associated token account, which we will probably get to. And then burning tokens is the opposite of minting tokens, where we just destroy them again. Fun fact, everybody can burn tokens. You don't need to have a specific authority to do that. You need to have an authority to create tokens though. You need to have the mint authority. So again, this tutorial will be very basic. I might go more into detail because the token program is such an important program. And today we use this SPL token library. So we'll be working with TypeScript again and not with the CLI. Starting with a token mint. Giving you some more detail here. I'm pretty sure that I explained most of this already. Example with the USD coin. This is the address for the token mint account of USDC. That's just something that you remember if you see it a lot. Not the entire thing, but the first few letters. If we look at this in the Explorer, we can see some detail. Wow, it doesn't even load the logo. We have the current supply, which is quite a lot actually. We have the mint authority, so this account is allowed to create more tokens. We have freeze authority. This account is allowed to have other token accounts be not able to burn or transfer their tokens anymore. And we have decimals. This is a concept that we should discuss at least a little bit, because that's what we need to define when we create a new token, and specifies the desired decimal precision of the token. Essentially, with USDC, if we only had 2 decimals, then we only could represent cents. If we had 3, then we could do a 1/10 of a cent, a 100th of a cent, a 1,000th of a cent, and we can do a 10,000th of a cent with this precision. So the smallest possible amount you can send is a 10,000th of a cent. Wow, is that complicated to say. But yes, that's the decimals. And the more decimals you have, the fewer tokens you can create, because the actual amount is only represented with a U64. Now, if you want more detail on that, I recommend that you check out my other video that you find up there that goes more into details about decimals and how many tokens you can create with each amount. NFTs, by the way, have 0 decimals because they should not be able to split. One token should always just be 1. And then there's also just 1 being minted ever. Right, but let's see what else there is. So to actually create a token mint, we call the create mint function. Wow, who would have thought? And that will return the address of where the token mint account lives. And we just need to provide it with the connection, because it then also sends that on chain, right? It interacts with the RPC for us. We don't even need to call that ourselves. So that's a very high level thing that hides all the connection, sign transaction and send transaction, all of that stuff. Oh, it's even actually here. It creates an account and then it does a create initialize mint instruction. And this will then also be sent. I mean, we can have a look in the actual SPL. So we have, oh wait, this is the program now. Then we have the CLI and the JS part. There we go. That's where those things live. And the create mint is what we were talking about. This internally just creates an account and then does the create initialize mint 2 instruction. They already changed it to a newer version. And then it sends and confirms the transaction, gives us the public key back. Pretty simple. So that's what it hides in the background. It also checks how much rent we need for this account. Again, the concept of rent we'll kind of touch on in a few seconds, I guess, or in a few minutes. So doing this, super simple. The payer, so we have the connection, the payer, obviously somebody needs to pay for this transaction, not only for the transaction fee, but also for the account, because the account needs rent to live on chain. Maybe we should talk about rent first. There, rent and rent exemption. Back in the days, in the old days of Solana, accounts had to pay rent to stay in memory of the validators, because, you know, that costs them something. And they had to do that in intervals, you know, every epoch. The way to avoid paying rent was to just deposit enough SOL to be rent exempt. And this enough SOL was 2 years worth of rent. Now, since Solana has grown, they decided that now every account needs to be rent exempt. And there are no exceptions. There is no paying rent in intervals anymore. Every account on Solana needs to be rent exempt to even exist. You can't create an account that doesn't have enough SOL to at least be rent exempt, right? And the amount of rent that you need to pay is dependent on the amounts of data you want to store. So the number of bytes that you want to store, plus the account header, which holds, you know, the lamperts and whether or not it's executable. So everything that a validator needs to hold in memory, that amount of storage you pay the rent for. Because most of the accounts were rent exempt anyway. Because if you close an account again, you can get the rent out. When you pay rent in intervals and you don't have enough SOL, then you lose SOL. Whereas if you just deposit enough, you don't lose it. You just have to stake it to be rent exempt. Yeah, and the get minimum balance for rent exempt mint basically just calculates how much SOL or how many lamperts, we know that's the SOL, but a billionth of a SOL, the native token has 9 decimals. If you think about it that way, how many lamperts we need to be rent exempt for the given size of a token mint. And that's inside this library as well. And yeah, the more generic one is just get minimum balance for rent exemption. And in this one, you can just add the number of bytes that you want to be rent exempt for. Okay, now back to here. We have the payer who needs to pay the rent and the transaction fee. Then the mint authority, which per default will also be the payer. This is the guy who's allowed to create tokens. So the authority to mint tokens, mint authority. Freeze authority, similar thing. He has the authority to freeze token accounts of that particular token mint. And if we don't want freezing, then we can just set that to null. And the other thing we need is the decimals. So we can specify the precision. The fewer decimals, the more tokens we can create in total. But the more decimals, the higher the resolution in the backend. In the end, it doesn't really make a difference. It's just a conceptual thing. When we're creating a new mint script, we can simply use the create mint function. So we can do this because we know the payer, and the payer, by the way, this guy will be a key pair. So actually, let's do this. Let's not just talk about it. Let's actually do it. All right. So we want to work with this library, which changes quite quickly, must admit. So that's why it's good that we do this. Let's just do this. And just to make sure, we npm install this package. And then we can include this create mint. And then we can call this create mint. So we need a connection from devnet and provide the connection. Then we need the pair. So we need to have some kind of a key pair. Let's see, what do we have from previous lessons? This Jamie, we just use that one. As we have learned in previous lessons, we load ourselves a key pair, call it pair because why not? And I want to load this. So hold on, Solana, there we go. So this guy has some balance on devnet, Jamie, and I still need to import that. I think that should work. Next thing we need is the mint authority. We'll just say, well, we are also the mint authority. By the way, before we provided a signer, which a key pair can be a signer. So here we provide a key pair, but a key pair is also a signer. But a public key, if we just say payer here, then does it just take that? Maybe it's smart enough to just take the public key from that. But to be sure, I would say dot public key just to make sure. To get the public key, then what else do we need? Freeze authority, let's say, is also us. And decimals, let's do the default 9 decimals. And then we can provide a key pair. If we wanted to have the token at a specific address, we could do that by providing the key pair for it here. Actually, let's also do that because we can. And in case you still don't know how to create a new nice address, Solana keygen grind, and then starts with, I don't know, my token MTO. And then how many of those I want? 1. I don't want to do too many characters here because then it will take forever to find it. There we go. We found one. MTO. We could now also do the same for the token and put this thing in here. Ah, there we go. It finally tells me that the key pair is not a public key. So yes, I am required to say public key here, and the same thing for here. Thank you. Just testing you. The next thing is the key pair. So we can have the token key pair in here because we want the token to live at a certain address, the token mint, that is. And confirm options, I don't think we need that. And the program ID will be the default token program. So we don't need to specify that. That's okay with me. Let's see if that does something. So we are operating on devnet and we try to create a new token. Module 2. Boom. Create account Jamie already in use. Okay, so apparently I did something wrong here. It tried to create an account on that address and that doesn't work, and the error for that is 0x0. So if you see that, then that's always an account already exists. Which of course makes sense because I didn't properly rename these things. Classic copy and paste errors. Obviously I took this secret in here and then I tried to create onto this key pair, which does not work. But it's good because we can now const token mint address, await this, and then log the token mint address as well, which will not be very surprising what that is. You will see in a second. Boom. Not very surprisingly, this is the address that we found with the Solana keygen grind earlier and provided this as the key pair. So the create mint created this account with this specific address already. So that's another feature that I really like to use because then I can have my tokens, start with a certain few letters. Because obviously it would be nicer if USDC would also start with USDC, but it doesn't because back then they didn't care about that. With this create mint, super easy to create your own token. And if we now check that in the Explorer on Definite though. Then we see, oh, this is an unknown token. It's a token mint with this address, and current supply is 0 because we didn't mint any yet. But Jamie is the authority for both minting and freezing, and we have 9 decimals. Then we also see all the transactions. So far we just created this mint. So far so good. Now this works because we can load this key pair directly from our wallet, because here we need to provide the signer directly. If we, like James writes here, work with a wallet where we just have the public key, then we need to do it manually. We can't use this function anymore, but we need to build the transaction ourselves, create that account, and then the create initialize mint instruction from the token program, and provide those things. And when we then send the transaction manually, there we can then sign with the wallet. So far, so good. I think I don't need to copy that code in. It basically does the same thing. If we then send that transaction with a connection, then we get the same result pretty much. Now, next thing, a token account. So far, we have a token mint account, but just a token account. Remember, that's the one that holds the tokens. How do we do that? How do we create these? Wow, wait. There's a create account function that we can just call. How easy again. Yeah, way too easy. But just to recap, the token account stores which mint, so which token it represents, who the owner is, so the authority to transfer, burn, etc. And it also stores the amount of tokens. Again, we can see that here. It also does a bit more. You can also have a delegate and the delegate amount and the close authority. So anyway, with a create account function, we can just create a token account. Wow. What do we need for that? A connection again, a payer again, the mint. So this time we need to say which token it is, who owns that token account. And then again, same thing as before, we can optionally say at which address this token account should live. Does James ever talk about associated token accounts? Yes, he does. Okay, so that's for later. Let's first understand just the token account. Yeah, let's just do this. Although before we do this, let's check what happens if we execute the same code again. Then we will see the same error again, 0x0. And that just means, oh, I cannot create a token for you at this address anymore. Well, obviously, because at this address there is already something stored. So we can't do that again. The way we would need to create a new token is to provide a different address here that is not yet used, or not provide this key pair here in the back. Then we can just create another token. I will select a random new key pair, and then we also get back that is now a random address where it created the token, right? We can also look at that. And once again, we will have a random unknown token where we are the authority. Okay, now back to this. Let's not create a new token, but create a token account. So create account. We do this, provide the connection, we provide the payer, so who pays the rent and the transaction fee. We say which mint, so this is the token key pair public key now. Because remember, that's just this address. We could also just create a new public key from this address, but it's in that key pair, so I'm going to use that. Then what else we need? The owner, let's say we create it for ourselves. So we take our public key, and then we can once again specify a key pair, or let's get another one, my token account, or just token account to make it quicker. There, TA for token account. We'll also have to load that. You know, at that point, it would make sense to create a function for this, Andy. Let's take this, put this here, which returns me a key pair. And then we just say this, and this account. There we go. And we can provide the token account key pair here. Now, if we execute that, well, maybe promise of ... create account function is different from the create account function shown above when we looked under the hood of the create mint. We used the create account of the system program. Yes, but that's a different one. We are now from the SPL. Yeah, so that's just something that we find in here again. You know, if you want to have a look in the actions, create account, no, close create here, that's what it does under the hood. If we don't provide a key pair, then it does the ATA, the associated token account. We'll get there in a second. But then we just get the information for the mint, because we need to know the decimals, find out how much space we need, then find out what the rent exemption for this is, and then create the account. So this is a different one now. This is the one from a system program. And create initialize account instruction. That's with a token program. So that is an instruction of the token program that we then actually send, and we get the public key back. I mean, we can pretty much ignore it, or we can await it just to have something that we print as a result to see that it worked. There we go. And surprise, surprise, it gives us the same address back as we put in up here. And if we have a look on the Explorer, then we see that this is now a token account because it's owned by the token program. The Explorer doesn't even tell us this anymore. It tells us this by saying it's a token account, because the owner of the account is the token program, but the owner written in the account, that's the actual authority. So this field should be called something like authority, not owner. But you know, back in the days, they named it that, so that's what it's still called. It's still Jamie. Yep, right. So we have a token account. If we wanted to do that manually, we already saw that's how we would do it. Before, we need to know the space and the Lamperts though. Now, before we start to mint tokens into our token account, I want to discuss associated token accounts. Because each of the token accounts that we create, they have an owner or an authority. But now, whenever somebody sends me tokens, they could create a new token account to do that. So create a new token account, put the tokens in there, and you're the owner of that. Problem with that, obviously, is that one person, aka one wallet or one address, will have several token accounts for the same token mint. For different mints, of course, you need to have different token accounts, but even for the same mint, you can have different token accounts. Like, I could go ahead and create another one with another key pair here and still put in the same owner. And that's inconvenient if you then want to transfer tokens, because they live in different token accounts and you need to have one transfer instruction for each of them, which is annoying. So people came up with the concept of associated token accounts. Now, what is an associated token account? It's essentially one account for a particular wallet and mint. So we derive an address, similar like we do with the PDAs. So you should be familiar with that concept. And we use the owner's public key and the token mints as seeds, you know? So this is deterministic, aka we will always be the same as long as we provide the same owner and mint, and it will return us a specific public key. And in 99% of the cases, you just want to interact with the associated token account, also called the ATA. If you hear Solana people talk about ATAs, that's associated token accounts. Because whenever I send somebody some tokens, I want to send it to their ATA. And this SPL token library already makes it super easy for us. We can just say create associated token account. Then we just don't provide the key pair, right? And the shortcut of this is not providing a key pair, which calls the create associated token account. Let's have a look where we find that and what it does. Okay, so it's a different instruction because there's also an associated token program ID. Yeah, so there's an entire program that is used to handle these things. But you can just do it yourself manually. There is a specific way how you derive associated token accounts, just that this program does it automatically for you. If you wanted to know how, you can once again go here, go to the associated token account program, and you will see what it does. Maybe I don't want to look at Rust code yet. I don't think we're that far. Get or create associated token account. There, get address. Yeah, things change quickly. But anyway, there is a way to manually do it. I'm just too lazy to look it up. And also, we have this nice function to do it. or we just don't provide this, and then we will also get the ATA. Let's do this. So the ATA for this particular mint and owner will be this one, the 51YF. YF. This is now again a token account. It doesn't know the difference that that's an associated token account for the Explorer. It's just a token account. How should it know? But yeah, it was created using the associated token program. So they've put that functionality into a program, so you don't have to manually find the right address, which they did before. And then it's the same as before with the token program. We create the account and we initialize account. Version 3 already. Okay, things change. Moving on, I think you understand the concept of associated token accounts. You understand the concept of token accounts, token mints, and we can be moving on to actually minting. Wait, so no, let's stay here for a bit longer, because we just talked about the get or create associated token account to get the token account associated with, or check if it doesn't exist. So this, we just looked at that, but that will also just query the associated token program, as far as I understand. By the way, the associated token count also depends on the token program. Who would have thought? Because if you have a different token program, then you'll get a different associated token account. But that's only relevant when you play with the token 2022, which we don't for now. So if you just want to check if the associated token account exists, we can do it like that. Well, actually the get or create will make sure it exists, because it also sends a transaction, as we saw. So this will make sure that the associated token account exists, because again, if we don't do that, and if we do that a second time, then it will fail, because obviously we get the 0x0 again, because we try to, provided owner is not allowed. Different error message, but I think the underlying error is the same. We have already created this ATA. So connection, payer, mint, token keeper, I called that. And allow owner of curve just says, remember off curve is a PDA. If I allow a PDA to be the owner of this ATA, which we can say false or true or leave it out entirely. This will now be our ATA. It was already before an ATA, but now it's especially one. And here we get back the account itself, and then we just get the address of the account. And this should now work every time, because it will just check if the account is there. And if it is there, then so that's why it's quicker now. We don't need to send anything. Only if we had a different token or a different owner, then this method would also create the ATA for us. I guess that's understandable. At least I hope so. But we can dig deeper though, because what that does is just it creates an associated token account if it doesn't exist yet, using the get associated token address to derive the associated token account address. Now this thing, creating it as well, we can say our associated token account is get associated token address of our mint for this payer, and that should then also return us the same thing. There we go, 51YF. Just want to go to implementation. There we go. Nice. I even have the implementation in here. I love it. So I don't need to go on GitHub. And maybe I just have an old version, but that's in the mint TS. So it's in state mint TS. State mint. Yes, that's the thing. Yes. That we also have here now. That's how you derive the address, because it's literally using the same thing as we saw last time, find program address sync. So same thing we use for PDAs. And we put the owner, the token program, and the token mint into the seeds. And we do that for the associated token program ID. That's how we derive an ATA. Just so if you ever want to do this manually, that's how I do it. Again, if you use token 2022, you need to have a different program ID here, which results in a different ATA, of course. Moving on. If you want to manually create, you can use the create associated token account, put it in a transaction, and then send that. I think that's all I want to say on ATAs. I think we covered that pretty well. Now let's continue with minting tokens, because for now, all of our token accounts still hold 0 tokens. We want to change that. And it's not too difficult because again, we have a function that does it all for us. And we just need to provide the connection, the payer, the mint, new, the destination, that's the token account, the authority, so that's the account that is allowed to mint the tokens. This guy is just the guy who pays for the transaction, and then the amount we want to mint, obviously. And this is the raw amount of tokens outside, not accounting for decimals. So you need to account for decimals. So say if you have 0 decimals, then you can just put in the raw amount. If you have 1 decimal, then you need to multiply it by 10 because decimals, 10, got it. And if we have 9 decimals, then we need to multiply it by 10 to the power of 9 because decimals. So compare Lamperts. You want to put in the amount in Lamperts and not in Sol if we put in the amount here. Yeah, let's do this. Mint 2. We have our ATA and we signature mint 2 from the SPL token library, provide a connection, provide a payer, provide the mint. You know what common practice is to call this mint, and we just, to make it easier for us, now call this mint. So that's just the public key of the token mint. So it just can write mint here. And then the destination, we provide the ATA. So we want to mint it into the associated token account. We could also provide, the other token account that we had here. I already deleted it. This one. Of course, I had the wrong one. Token keeper, of course. We could also mint it into this one. Anyway, good that I scrolled up there, found an error. Then the authority, we are the authority because remember this guy away in the account. Sorry. If we go to the token, the authority, this guy, only this guy can mint. So we need to say we are this guy. And the amount as a number, let's just say we want to mint, 3 tokens. And then we need to multiply that by 10 to the power of decimals. No. And our decimals, we hard coded as 9 here, but we could have done this. And so 3 times 10 to the power of 9. If we do that, let's also log our signature. So the ATA exists. Cool stuff. And let's see if we get a signature. Yes, we do. Works. We can check that out where we see we've paid. So this was the payer. We paid for the transaction. And we got 3 tokens. And in the entire amount, it was the 3 with that many zeros, 10 to the power of 9. That's just a mint2 transaction, a mint2 instruction on the token program. Yep, pretty simple, right? I think there's so much more stuff now happening since we have new transaction types. Anyway, Solana is developing so quickly. Yeah, and that's how I mint tokens. It's so freaking easy. Where are the good old times where people asked me to mint tokens for them because they didn't understand it. Okay, moving on. What does James say? It's not uncommon to update the mint authority on a token to null after the tokens have been minted. Yes, that's how we create a fixed supply. Otherwise, could keep minting tokens as we like. Again, if you want to look under the hood, there's just a create mint2 instruction on the token program. Yeah, so that's also part of the token SPL token. If we create a mint instruction, put that in a transaction and send that, that's essentially all that happens. Right? Simple. Okay. Keeping it as simple as that, transferring tokens. Once again, we're literally just calling functions. What does transfer do though on a high level? Well, subtract the amount on one token account and add the amount on another token account. As we had with the system program transfer, the token program transfer does the same thing, but on a token account level, not on an account level. So if we have both token accounts, we can just call transfer. Let's do that. What do we need? Well, the payer again, who pays for the transaction, source, destination, those are the token accounts, the owner, so the authority for the source token account. We don't need to be the owner of the destination token account, can be, but we don't need to. And the amount, again, with decimals that accounted for. So let's do that. Let's send it to our other token account. Just gonna do that because we already created it. So store it as TA. And usually you'd have a different receiver, but I'm lazy. So I'm not gonna do that. Gonna ignore that for a second and say our signature is now awaiting just a transfer from the token program, again with connection, payer source is now our ATA, destination is now our token account, and of course the owner or signer, let's say it has to be the payer, I'm just being tired. And the amount, let's say 1, just so you see what happens if I type 1, okay? This is not going to be 1 token, because 1 would be 1 times 10 to the power of 9. But we want to see what happens if I just have 1. So again, maybe just log this and give it a go. Again, this is very, very basic token program interaction with the simplest functions. If we have a look what's happening here, we again pay for 1 transaction. We need to specify the accounts that we operate with. So source, destination, and the token program, of course. And now look what happens. I transferred 1, but 10 to the minus 9 tokens. So just 0.0000001 tokens to the other token account from my associated token account. And that's the result. Just so you start to understand what's happening here. If you're doing this and you would expect a 2 here and a 1 here, then you forgot to multiply the decimals into your amounts field. Yeah, but again, just 1 instruction on a token program, this time a transfer instruction. Simple. Go in here. Once again, under the hood, just to create transfer instruction. And who would have thought that when we burn tokens, it's gonna be the exact same. We just need to provide a connection, a payer, an account. So the account we want to burn the tokens from, that's a token account, the mint, because we need to also provide that account now because it changes the total supply, and that is logged in here as well. If we burn tokens, we need to provide the mint account so the total supply can be decreased. Of course, we need to have the authority for the account, and we need to say how many tokens we want to burn. So let's say I'm unhappy with how many 9s there are and I want to burn them all. Burn them all! I go here, calculate my amount to burn as 1 token minus 1, so 1 billionth, and then I can call burn, which takes once again a connection, the payer, the account, the mint, and the owner, which is again my payer. Yeah, and of course the amount to burn. Pretty simple. Let's just do this and see what happens. There we go, 5G. If we check out this, all that's happening is we pay for a transaction, and this time we also provide the mint here, as I said, and it needs to be writable. So the token account and the mint both need to be writable, because at the mint, let's check that out, the current supply is now 0. What? No, the current supply is now 2, and the 1 on the other token account. Going back, so we burned all those 9s to have a clean 2 tokens. Yeah, and it's done by just another instruction on the token program. Who would have thought? The burn instruction. Burn instruction, and that's it. Pretty simple, huh? So we can create token mints, create token accounts, create associated token accounts, mint tokens, transfer tokens, and burn tokens. Yay! We can build dApps now, because that's all you need. You like tokens, right? With that, you can already do quite a lot. So what else is there to learn, James? I mean, that's pretty much it, right? Oh, you want us to do stuff ourselves? Man, I thought we were done now. So, demo. So what James does here is just creating a new project in a certain way, which I think my big main function is just good enough. But just to learn something, I want to see what that actually does. What does that thing do? Oh, it will also create me a package JSON and everything. Okay. And give me an index for a main, which already creates as a connection and initializes a key pair, which we have here. Right. So that's stuff that we learned earlier, right? And we airdrop some Sol if we need that. Yeah, I mean, that's nice preparation, James, for somebody who just wants to get started with something. But since I did the previous lessons and I have pretty much all of that already here, I'm good with that. So, and then all he does is create a new mint and log it with a pretty link to the DevNet cluster in Explorer. And then we create a token account into that. And then we mint tokens into that. and then we transfer tokens, and then we burn tokens. So essentially pretty much the same. Test it all out, right? So he creates a token account, mints tokens, creates a new receiver, creates him a token account. That's a thing we didn't do, but we could have, for the receiver, we once again need a token account, and then we can put this address, source and destination, and send them 50 and burn 25. So he just calls the same functions with a bit different values. Not gonna do that again. However, I will do the challenge with you, right? Because this looks like Frontend again, and we want to do some stuff. Now it's your turn to build something independently. Yes, my dear viewer, you can now build something independently. You can stop watching this video now that you know so much about the token program. You can do stuff by yourself. Nice. Am I being sarcastic today? Yeah, maybe a little bit. Note that you will not be able to directly use helper functions we went over in the demo. Oh no, because we don't have the key pair directly. We don't have this anymore. Oh no, we need to do it manually. Oh no. In order to interact with the token program with the wallet adapter, we'll have to build each transaction manually. At least a little bit of a challenge. Now, what do? You can build this from scratch or start with a starter code. Well, obviously we start with a starter code. Am I crazy building front end? Hell no. So we're on starter branch, Solana token frontend. I did not clone this yet, so we're gonna do that. Git clone cd Solana token frontend. What's inside this Solana token frontend? I ask. Token frontend. Here we go. Some components, some pages, some public, some styles. That's probably not important, not important, not important. Probably we're gonna work in here somewhere. All right. But we're just gonna npm run dev to see if that thing starts. Probably need to npm install all the dependencies again. And suddenly we can run our dev server. So if we go to localhost port 3000, there we go. That's the base. Oh, also I went into the intro frontend. Stupid. They're called two similar token frontend, and I can't read. Same thing again. npm I. No, what's happening here? Oh no, version incompatibilities. I hate this. I hate front-end stuff. Conflicting peer dependency. Let's see if it's because I have in the parent directory some stuff. No, it's not. Starter, I think, was the branch, but also here probably the same thing. Yeah. No longer maintained. But interesting. I changed to the starter branch and suddenly I could update or install my dependencies. I'll take it. Easy to fix. I'm just on starter branch now. That's cool. I'll just run it again. Yeah, there we go. And now we should have the right front end. Yeah, there we go. We connect our wallet. Hold on. Let me just get one. And connect. Cool. Still have some salt balance from last time. There we go. Enter a token mint and a token account. Create mint. It does nothing. Create token account. Please fill out this field. Mint tokens. Please fill out this field. Okay. Create mint does nothing because it's not implemented. Well, let's implement it then. That's the challenge. So we download the starter code. Then create a new token mint in the create mint component. Create mint component. We can find this. Create mint component. Cool. So let's have a look at this. What is happening here? Build and send. Easy. Just do it here. Insert your code here. The event on submit comes in here. We get an event. And if we don't have a connection in a public key, then we return. Okay, cool. And then here we should just create a new mint. Connect your wallet. And if we have a transaction signature, we can use with settxsig. All right. Well, let's do this then. Challenge accepted. We do the following. We create a mint. Just that we can't do this directly. We need to manually do create mint. That's not how they named it. How did they name it? I need a refresher. Create initialize mint instruction. That was it. Create initialize mint instruction. That thing is now imported from the SPL token library and it needs a mint a public key. So let's just say const mint new key pair. Just create a new random key pair. So the mint public key. Then the decimals, let's use something different for fun. Just use 3. Then the mint authority. Now this is going to be our public key that we get from Phantom, from our wallet adapter. Freeze authority, let's say we don't allow freezing for this one, so we put null. And the program ID will be the standard token program, so we don't provide that either. That's that. And then we get here our instruction, which we put into a new transaction. Okay, let's say web3.transaction, because we imported web3 like this. Fine with me. Transaction add instruction and create initialize mint instruction. However, before we can do that, we need to already have the account. That's for the, and then we first need to add, create account is also a very bad name. It's so confusing. It's all accounts. Nah, I don't know. Just IX. F it. That's a system program create account. Or, I guess it's fine. Because what that returns us is a transaction instruction. Okay, perfect. And it needs parameters like a from pub key, mint. Lamperts we get from await, get rent, get minimum balance for rent exempt. Mint already has that. I mean, should we just use that? And that's the most convenient thing to do, right? We have a connection. Yeah, why not? That's the easy way. Oh, new account pub key, that's this. So this is then from pub key is my pub key. I get it. Okay, cool. What else do we need? The program ID. So that's the owner of the account now. And that will be the token program. So that's the token program ID. And then, although let me check if that's a public key. Yeah, that's a public key. Okay, perfect. Perfect. And then the space that we also kind of need to know the space, which is in mint size. Haha, all right, it's already in there. Okay, so mint size that we can just also import from SPL token, the library. Cool. So that's the first instruction that we need to add, and then we can add the initialize mint instruction, or we need to execute it in that order. Right. So far so simple. Const, I like to call it this now, signature is send transaction from the wallet with this one, this send transaction that needs a transaction and a connection. Send transaction needs a transaction and a connection and returns us a promise for string. Perfect. So we just await this promise and then we get the string back, and then we can set, what is it called? Set tx sig to our signature. And once there is a signature, it will display it here nicely in the Solana Explorer with that link that James already prepared for us so neatly. Let's save this, go here, reload this just to make sure, and see if we can click that button. Nice UI. Click. Oh, look. And see, now we have to pay 0.00146, which is the cost for the rent of a token mint account. Approve this, and nothing happens. Why nothing happens? Because uncaught in promise. This is the key pair. And if I want to create this account, then I need to prove that I can sign for this. So maybe that's my problem, that I also need to add a signer. Let's see, can I do it to the add a signature to this send transaction? Because it's just the transaction that I put in here. I can put additional signers. Perfect. And you need that as a what? As a array of signer. Perfect. So an array of a signer. One such signer could be the mint, a key pair we said earlier. Maybe that helps. Try that again. Create mint. Approve this. Ah, there we go. Yes. Nice. And we can click Solana Explorer and we see the token that we just created, or the transaction for the token we just created. Oh wait, that's me. I had to pay this, and that's the token mint. Still has 0, and we see here 3 decimals. Cool. So, I mean, that worked. And the reason why this didn't work is the create account. If we want to make it on a specific pub key, obviously we need to own this. And here we just provided this public key. We could also, did James do that as well? When he did it, did he provide that account key pair somewhere in the connection? Not really. That's that part done. Then create a new token account in create token account component. Build and send create token account transaction here. We already have everything prepared in the import. Well, but I mean, that's cheating, so remove that thing. We have a connection, we have a pub key. We create a token account by doing pretty much the same thing as we did before. So this stuff, I'm gonna copy that for a second. Do I know which mint I should use though? We have an input owner and we have an input mint. Could I just dot target dot first value? I mean, that's probably not a nice solution how to get that, but maybe. Yeah, but I mean, that's how we get the values. I mean, it does what I want it to do. Yep, I guess that's how we get the values. I'm not a front-end guy. So the mint is this. The token account owner is this. Right here, a new public key. Cool, that's how we get our values. Our lamperts are not get minimum balance for rent exemption mint, but account now. And then we do the same thing with the system program. Yeah, but the new account, this is now gonna be, wait, should we create a token account or associated token account? So let's do the ATA, why not? Let's do the ATA. ATA is get address for this mint and this owner, and program ID is the standard. Cool, works for me, and returns us, it doesn't say return address of the associated token account. Perfect. Just await this. I have the ATA, then we create this ATA. The token program is still the owner. We import that, and the space, it's so convenient. It just tells us all of that stuff already. More convenient is still this, where I just call one function and it does everything for us, like the one function for create account. But this is still very convenient where we have all those functions here. We can still dig deeper and also calculate the size, the space ourselves, and then use the get minimum balance for rent exempt without account. Okay, so we have the create account, and then instead of the initialize mint, we create an initialize account instruction, which takes the account, so that's the ATA, takes the mint, that's the mint, takes the owner, that's the owner, leave it out, and it takes the token program ID per default. And then I put all of those instructions into my transaction, and then I hit the network with that transaction, and I don't need that as a signer because I get this feeling that it won't work because I'm forgetting something here. Maybe I should not do it like this, but let the associated token program take care of that. Well, we will see. Let's set signature again in case of success. Worst thing that can happen is that it fails. Oh man, that will be bad. Let's create a mint proof. Oh, then we need to here and copy this and then put this in here. Copy my address and then I create a token account. Ooh, looks good though. Yes, that's the size of a token account. Well, that's the amount of rent required for a token account. I've seen this number a lot of times. Approve. Damn, we do not have the right signatures. And let's cheat a little and check how James did it. Well, it's just a create associated token account instruction from. Maybe we don't even need that part. We'll see if that works. So that's just my public key. We pay for this, no worries. The ATA, okay. The owner, okay. The mint, we have that. And yeah, the program ID and the associated token program ID with take the default ones because we don't want to work with token 2022 or any of our own token programs. And we pump that into a transaction and just send that. Maybe that already works. Maybe all the magic is already in here. Let's see. And approve. No error. For me, it's a win. Oh, and we even here have a link to the Explorer here. Amazing. Went through. We created an ATA at 4U44. And it used the associated token program and the token program. That's that part done then. Mint tokens in the mint2 form component. Well, that can now not be too hard either. Mint2 form. Once again, if we check out how that looks, we have the token mint, the recipient, and the amount, which we're probably gonna get again in a different form through the event. Let's see. And the amount is that gives me a number. I don't know TypeScript. But if it works, it works. Let's see. Amount. Let's log that just to see if that would theoretically work. Wait, is the recipient supposed to be the token account or the person receiving? Oh, and then I put myself in. Okay. And EG 100, mint tokens. Yeah, that looks good. So we got the 100 as a number. So that seems to work, getting out of the event. Now to the easy part, which is mint2. So we create mint2 instruction. Is that from the SPL token program? I hope so. Yep, it's from the SPL token program. Perfect. And what this thing needs is the mint, is the destination. Should we assume that the token account is created? Yes, because there's another field that lets us create token accounts. We just provide the mint, the recipient, and that's it. Then we get the ATA. The ATA is the destination. Must be my public key. Because obviously, if I'm the only one signing here, really. So if I don't have the authority, then I can't mint. And then the amount and instruction that we then put into a transaction that we then send on chain. And then probably we have a set tx sig again for the signature. There we have it. I mean, pretty sure that that's enough because a mint is a pretty simple instruction that doesn't really need anything much, and we don't need to create new accounts anymore. So it's really just interacting with the token program. So this should work. We should now only pay the transaction fee. What? We get one NFT? Yes, Phantom. That's what's happening. We get one NFT. Token balance says nothing. Maybe I need to implement that as well. But if we click here, then we see we just paid the fee. Oh, because I said 1,000. I randomly put 1,000 and randomly that was exactly one. And then Phantom thought, oh, it gets one token, and then it made it an NFT. It's not an NFT though. It's not at all an NFT. Because it's highly fungible with 3 decimals. Yeah, I randomly, how fun. Because obviously what I'm missing here is when I get the value, I need to multiply that with the decimals. No, with 10 to the power of decimals. And the decimals in our case is 3. So if we just want to put in the amount, then we need to do that. Obviously it would make sense to read which mint that is. Pass the token account, read the decimals. Man, do you want to do that? Do we want to do that? Do we want to? As an exercise, maybe? Just real quick? Because I hate hard coding stuff. We want to find out what the decimals are. Okay, this is quick. Believe me, this is quick because we know what we do. We have the mint. We can just say account info, get account from the connection, get account info for that mint. That gives us the account info. Remember, that's a buffer. And now we just need to know where in that struct lies the amount of decimals. Conveniently, we already looked at that earlier. It's a mint struct, which contains first the mint authority, then the supply, then the decimals. So we have a U64, which is 8 bytes, and then we read a U8. So that's 32 plus 8 is 40. So essentially we just say account info data read U8 with 40 as an offset, and we get the decimals. We can also log them if you don't believe me. Now, the cleaner way, or the whatever, if you wanted to, work more with it, then you could build a Bosch struct and then decode the account info as we learned in the previous lessons. Look at those if you're interested. Linked somewhere above if I'm not too lazy to forget. And yeah, now we can use those decimals because we just read that from that account on chain. Yes, cool. That's much cleaner. I like that. Much better. Okay, let's see if that actually works. And then maybe just say I want to mint 1.5 tokens. The number 1.5 cannot be converted to big int because it's no longer an integer. Should I check if the account exists? Public key, get that account info. Come on, this can't be so hard. Why is that so hard? The mint authority, why does it have 36 bytes? Can you explain that to me, why I need 36 for the mint authority? But okay, I'll take it. If you say it's 36 bytes for the mint authority because you need 4 bytes to indicate whether or not it's an optional or whatever, fine, I take it, your layout. I accept it. Which means our offset is 44. Yes, 44. Okay, our offset is 44. Fine. At least I know where I need to look to find out what my error is. Now, with 44, we hopefully get the right decimals. Yes, we get 3 decimals. Oh, nice. And we also get the... Yes, that's much better. Yes. Oh, we get 1.5 NFT. Phantom. Not everything is an NFT. You need to do the basics. Phantom, watch my basics classes, because you learn that it's not NFT, it's a fungible token. Dude, we have decimals of 3. How can that be an NFT? Anyway, I'm gonna approve you anyway. Now that we have that, we can see that at least the amounts are now correct, and I actually get 1.5 new tokens. I mint 1.5 for a total of 2.5 tokens, because that's the number that we actually put in as the amount. Yes. The weird thing, it was just token balance. Where does it get that from? That's one thing that I just need to set. We don't really have the balance, to be honest with you. But again, as an exercise, we can get it because it's not that hard. Where would that balance be? Well, of course, inside the token account. It's written inside the token account. In a token account here in the amount. So offset 64, we can remember that. Offset 64, and it's just 8 bytes. So I use 64. If we want to query that, get account info on my associated token account that we have from the receiver and the mint. So there we get the info, and then the same thing as before. We just read new balance is data.read big int 64 little endian. And the problem that we will encounter here is here we send the transaction and we await the signature. However, this is not confirmed then. So the state is not persisted yet. So we would need to wait longer. Yeah, that's how you do it. Finalized. I want this to be finalized. So I want it to be approved by the validators. And until that is the case, I will wait. And only then will I get the balance. So we can say, although it's probably not nice to do this inside this button event, but hey, I'm not a front-end guy, so whatever, I can do whatever I want. And then we read the balance. So let's see if that works. 1 token. And then now it's unknown. It's not an NFT anymore that it's now 1. Approve. So we're waiting. No. Transaction was not even confirmed in 60 seconds. But if I click here, I see that it is confirmed. My new balance is 3.5. If I leave that out, by the way, then I'm assuming that if I now do this thing again, it will tell me 3.5 no matter how many I mint. 1.5 unknown. Okay, now it's not an NFT. See, then I will get 3.5 because I didn't wait for the new state. I just read the account immediately after I put out the transaction, which obviously is not the state anymore. We are already at 5 tokens. While we're doing this, we might as well do it right. set the new balance by dividing it to 10 to the power of decimals. And we wait again. Approve. Oh no. Damn it! I clicked away. Okay, I ruined it. Oh, I mean, finalized is for all the validators. Let's go with max. If I have max, that should already be enough, I guess. Let's try that once real quick. Waiting. I mean, this is already taking way too long because we already have max confirmations. It is finalized. I'm doing something wrong. I cannot await for a transaction signature, which is something that we should have probably learned in lesson 1 and probably did learn in lesson 1. Super strange that I can't get this to work. Well, Solana programming would be too easy if everything was working. And stubborn as I am, I would probably spend the next few hours trying to fix this. And at the same time, I have better things to do. So, we're just gonna await nothing for 20 seconds. And then it should be fine, right? I just want to make this work. I just want to have this work. Let's see. Hopefully it still starts. So if we look in our token account, we currently have 6 tokens. If we go here, refresh that, and add another 0.6, mint, approve, and then after 20 seconds when... Damn it, too early! Did I just wait 2 seconds and not 20? Of course I waited just 2 seconds and not 20. Always the thing with the decimals. 3 decimals because milliseconds. Do that again. We add another 0.4. If we refresh, now we have 6.6 tokens. We can also see that here, 6.6 in the current supply. If we now add another 3.4 and wait 20 seconds, then we finally get the result that there's a 10. Suddenly the 10 pops up. Ah, how nice. We also made that work. It's an ugly hack and doesn't do the thing that it's supposed to do, but at least it works. Good enough for me. I hope that you had as much fun doing this challenge as I had, because I had so much fun. And I'm not being sarcastic at all tonight. This means we are now done with the first part of module 2. We can now deal with the token program. And let me tell you, in a bit bigger, the token program is so much more than what we just learned. There's still the freezing. You can freeze token accounts, not the token mint, but the individual accounts. Then there's delegations, and there's just so much to learn with the token program from here, but those were just the basics, and this video definitely is long enough, and we are discussing just the basics. And the real thing that you should take away from this entire endeavor here is that we can interact with programs that are already on chain and do productive stuff. We don't need to write our own programs for everything, especially if it's about tokens. There is the token program and the token 2022, which again has a bunch of features and deserves an entire video series, but not here, not now, not yet. Anyhow, I hope that you learned something in this video and it wasn't too boring, even though most of you probably already know the token program. I mean, I do by heart, but hey, I learned something today, that the confirmed transaction doesn't work anymore. Yeah, thank you for watching. Check out those videos. So weird. I shouldn't look at my fingers. Anyway, those two, you know, check out the videos. Like, subscribe, and tell Jacob that I'm doing a good job creating those videos. And then I will see you in the next one.